So when you have a non-right triangle, we have two laws that help us out, the law of sines and the law of cosines. You use the law of sines if you have a complete pair and you want to compare it to another ratio, like an angle and its side length. But we don't have a complete pair here. We're missing the angle in this pair. We're missing the angle in this pair. That's why law of cosines is how we're going to have to at least start off this triangle. So in blue is the law of cosines, where little c is a particular side length, and cosine capital C is the angle of that corresponding side length. So in this case, there's only one angle that we have to use, 92. So that means its corresponding side in our formula is going to be the little c. And it doesn't matter what a squared and b squared are, because you're adding them. So the whichever one you choose for a, be it 4 or 3, the formula is still going to work out. Just like with the Pythagorean theorem, the c is the most important part, making sure you get the hypotenuse right. Everything else doesn't matter. So we have 92 degrees to work with. We're going to plug that in. We're going to plug in cosine 92. And then we're going to try to solve for c. That's what it looks like when you plug everything in. And then you can use calculators, whatever you want to simplify. Just make sure in your calculator you don't mess anything up with the cosine. Do cosine 92, and then you can do 3 times 4 times 2 after that. So that's what I got out of my calculator when I did cosine 92, then times 3 times 4 times 2. And to simplify that further, I got 25 minus a negative, so plus 0.8376. Or in other words, c squared equals 25.8376. So by now, in whatever course you're in, you probably know to take the square root to cancel out a squared. We're only going to consider the positive. Normally when you use a square root to cancel out a squared, you've got to remember to do positive or negative, because there's two options. But in this case, we're talking about the length of a triangle, so we don't care about the negative option. So we got roughly 5.083 for c. 5.083. Okay, and so to solve the triangle, we really got to know all the other angles. So to find out the other angles, now that we have a complete pair, we could use the law of sines, which is way quicker. You could use the law of cosines if you wanted, and solve for an angle instead of solving for a sine length. But law of sines is always quicker. So when you set up the law of sines, it's sine of an angle, like the angle we have right now is 92, divided by the side length of that angle, 5. And you set that equal to a ratio that you're trying to solve. Let's say we're trying to solve for this angle here. That's what the ratio looks like when you set it up. Sine of an angle divided by its corresponding side. Sine of this x angle I want to find divided by its corresponding side. So that's what sine of 92. Sine of 92 is. And then I always teach my students to cross multiply. So you can cross multiply these guys, cross multiply these guys. So this times this. Then we got this times this. So something we can't compute. So the 5 goes on the outside to show that it's being multiplied. And so now to get x by itself, first, that's 5.083 times sine of x. So let's undo that with division. And now to get x by itself, it's kind of stuck in the sine jail. So you use sine to the negative first, the inverse sine of both sides. And then what that does is it breaks down that sine, so you just have x by itself. So we just need this from a calculator. We get 51.856 for x. So there, we finally found out another degree. This is 51.85x. I said x, but I meant degrees. So that's how many degrees that is, and then you can find out this other degree by saying it's 180 degrees for a triangle. So take 180 minus 92, and then minus 51.86. And there we go. Now we've solved the triangle.